Hello and welcome back. So what is exactly Materia? Materia is an application, a plugin capable of producing a convex polyhedron isosurface. Basically it's a geometry with a very consistent polygon flow. As you can see, the polygons in the geometry are basically of the same size almost. There is a really little distortion on some sensitive areas, but overall this is a very consistent geometry which will play very well when applying shaders that use a word screen coordinate system. So now let's take a look a little bit at the interface. We have the usual toolbar buttons. You can basically click new to generate the surface again. You can save and load presets back. This is very important. Say you have you spend some time trying to find the right settings, then you can save and eventually load back the presets. You can reset the values in case you mess up the values and you want to get back to default to factory settings. Then we have the live button, which is very convenient in case you want to alter several values at once without having the simulation run each time. So you basically move the sliders or alter the settings, and when you're done you press new again and the simulation will run. I'm going to set live back again, and I'm going to reselect the 1 meter cube, which is working pretty well with my 1 meter size sphere. Alright, so let's see. I already explained about the presets. It's a good advice to start from an existing one. So if you have a genesis or a character, a humanoid character, you just go with the humanoid preset, and that will make things faster and will be calibrated with the right settings. Then we have presets for small, medium and large animals. We have presets for 1 meter plane, cube, and 10 meters plane and cube. So in this case I'm going to use again the 1 meter cube. We have the shader list box, which right now has only the really has no shader, of course. And then we enter the actually the interesting Materia settings. The volume step basically is the resolution of our of the generated isosurface. So now basically the grid, it's the grid size is this one. Let me show you. So this is the grid size. Basically you have to see this as a bounding box made of tiny little cubes of this size, and that reflects on the generated geometry. So if I increase the volume step, basically I decrease the resolution and detail of the generated mesh. So now, if compared to before, we have now a grid that is larger. So I'm getting less polygons with a larger area, and as you can see we are not getting the same amount of detail as before. Alright, so let me delete this. Then we have the volume size, but first let me set this back. Alright, the volume size is basically establish the boundaries of the simulation. So the generated surface cannot exceed these boundaries, and as you can see, these are basically the boundaries of our volume, these blue ones. So it's not a good advice to use a 100% volume size because that is very tight, and since the geometry generated will easily exceed the boundaries, you will end up with some part of the geometry not being generated. As you can see, they are being cut off, so everything that goes in Materia, everything that happens, it's inside the volume. So it's good advice to set it at 125 or 150. Of course, the larger the volume, the larger also the number of calculations that the software has to do. So my advice is maybe doing getting at most at 150%. That should do. Okay. Then we have the threshold. A low threshold will basically lead to a large geometry. The particles below a certain threshold will actually have a higher connectivity. So basically they will create a lot more geometry, as you can see now. If I increase the threshold, we are going to get more sparse geometry, as you can see in a minute. So you see with the higher threshold, basically some relations and connections between the particles are broken, and this is what I get. This might be an interesting effect for some purposes, I don't know, but usually the threshold is a setting that you want to leave at 1. And then we have, okay, so now this is where the microphone just dropped dead, and so I'm going to continue doing a voiceover. Sorry for that. So I was talking about the volume points. Alright, so volume points are obviously an important setting. There is no need to use actually an incredible amount of points, because Materia is going to discard and disregard some of these points. Basically only the particle points matching some conditions will be actually included in the simulation. In fact, you see that now we asked for 20,000 points, but probably we got no more than 200 or 300. There are just few, because that's what is necessary to produce a consistent geometry. So my advice is not using a insane amount, just go by steps. And in this case, given that we have just a sphere model which is not too complex, we are going to be satisfied with the 200 points. Okay, then we have the blob size. I think I was drawing something to explain what a blob is. A blob is basically a virtual sphere growing around each particle center, and these spheres are later connected to each other by the algorithm which evaluate each of these spheres called blobs, and by connecting each of these blobs is going to generate the final mesh, the final geometry. So it goes without saying that if we set a larger size for each of our blobs, we are going to get a larger surface, and not necessarily a very detailed surface. Probably we are going to get a geometry which doesn't have a lot of details, maybe a surface which is too smooth, like it's probably going to happen now. So this is the geometry that we generated, because the particles, the blobs, are so large that are basically going to be very uniform in their output. And as you can see, we also have some of our geometry being cropped when it reaches the volume boundaries, which you can fix increasing the volume size, or better, reducing the blob size. So reducing the blob size, we get much more definition for our geometry, and I think this is a much better look. But of course, that depends on what you need to achieve. Then we have the minimum distance, which basically evaluates the distance between each particle point. Using a low minimum distance will allow for more particles being produced. So more particles equals to a larger geometry in terms of polygons. While using a higher minimum distance, we are going to discard several of these particles, and we are going to get a sparse geometry. In this case, it looks like we have some water drops on the underlying object. So my advice is to choose to experiment and choose the proper minimum distance setting. And of course, using existing presets is a very convenient way to do it quicker. Okay, I believe at this point, no, I wasn't done yet. Okay, yeah, it's 7 is good. Okay, so I think we are now going to see the accumulation, and because the accumulation is going to produce more geometry, I increased the volume size so it will not exceed the existing boundaries, because the accumulation will actually increase the number of points, of particle points and blobs, and therefore geometry being produced. So this is what is going to happen now. As you can see, we have this sort of accumulation on top of our geometry, and as you can see, in fact, the particle points are scattered along the vertical axis in this case. So this is what the accumulation is. So just remember, when you use accumulation, a wise choice is to increase the volume size. Okay, so now we are going to take a look at the slope cover before, then the altitude cover. So the slope cover basically allow Materia to produce geometry where the angle formed with a specific point on the object surface and an up vector is within the value specified in the interface. So here I just was drawing the vertical, the up vector, and a series of normal vectors hitting the sphere surface. Normal vector is just a ray that hits the surface, forming a perpendicular, forming a 90 degrees angle with the tangent. So basically, to show it visually, if we use a 45 degrees slope cover, we are going to to produce geometry in that range formed with the up vector. And of course, that is going to happen also on the left side of the sphere, as you can see. if we are going to try a 90 degrees value, we will basically cover half of the sphere, because as you can see, the 90 degrees are extending from the up vector, and if we use 180 degrees, we are basically going to cover the sphere almost completely. Now in this case the geometry is sparse because of the pre-existing values, but I believe I changed the threshold, making it lower, so that the geometry will be covering the surface in a better way. So setting it at 0.75 is going to make the geometry. Okay, so altitude cover is going to use not the height of the underlying object, but the range of the valid particles being scattered in the volume. So a 50% altitude cover will start to cover the geometry partially, and when we increase the value, of course, we are approaching more and more towards the end of the underlying surface. But there is, as I said, a certain degree of tolerance, because it's not going to mimic the height of the underlying object perfectly. So also, as you can see, an 100% altitude cover will still leave some the bottom part of the sphere not covered, and that's normal because the algorithm works that way. Okay, as you can see, each time that here I was explaining the overlay button. You can basically show or hide the volume bounding box, which doesn't get rendered anyway, so shouldn't bother you too much, but anyway, it's there, so you can eventually switch it on and off. And every time that the simulation runs, the Materia node is being deleted and recreated, and it gets the real snow shader applied. The real snow shader is very complex, and I will explain it in a separate movie. Just know that it's very, as much as Materia is important for generating a nice looking ISO surface, the shader is going actually to exploit that much more, and you are going to get very nice results. I'm going to show you briefly the array preview for this node, and it goes without saying that you can always apply different shaders to the generated geometry. So as you can see here, I'm going to apply some car paint and water and other types of shaders. So I mean, Materia comes bundled with a very nice real snow shader, but nobody forbids you to use any kind of shader that you have in the library. So this is up to you, and I believe this is going to be a very interesting plugin and system to be used for your artwork. So now I'm going to stop. Sorry for the technical issues with the microphone. It's not working properly, and I hope my English was sufficient to understand everything. See you later. Bye.